Welcome to This Explainer. Today, we are diving right into the urgent April 2026 CSA advisory regarding critical infrastructure PLCs. Look, this is a severe warning, absolutely, but more importantly, it's a massive wake-up call about how we actually architect our operational technology. We're going to unpack exactly what's going wrong out there and how you can rebuild your networks using secure-by-design hardware.
Let's kick things off with a statistic from the internet monitoring firm Census that honestly kind of blew my mind. 74.6%. That is the percentage of globally exposed vulnerable Allen Bradley PLCs located right here in the US. To put that into perspective, we're talking about roughly 3,900 exposed devices out of about 5,000 worldwide. That is a highly concentrated national infrastructure risk. And, it tracks perfectly with Rockwell's market dominance, which unfortunately means US operators are bearing the absolute brunt of this targeting. And we need to be clear, this isn't just theoretical. Reading directly from the joint advisory, there is an, quote, active, ongoing campaign by Iranian-affiliated advanced persistent threat actors targeting programmable logic controllers. Agencies from CISA all the way to the EPA have confirmed active, real-world exploitation of these internet-exposed controllers. Real disruptions have already happened. So yeah, this advisory is pretty much mandatory reading. Our roadmap today is straightforward. We'll cover 1. The critical infrastructure threat. 2. Unmasking architectural debt. 3. Immediate mitigations. 4. Secure by design controllers. And 5. A practical selection framework. Let's get right into it.
Section 1. The Critical Infrastructure Threat, Unpacking CISA Advisory AA26-097A.
So what are the actual mechanics of this attack? Well, Iranian-affiliated actors are primarily hunting for internet-facing Allen Bradley PLCs, specifically the Logix family, and potentially Siemens S7 devices too. The main mechanism they're using? It's actually a 4-year-old vulnerability, CVE 2021-22681. It involves a hard-coded cryptographic key that lets unauthorized apps just bypass authentication entirely. To stick around, they deploy DropBear SSH, which is a really lightweight remote access tool, straight through port 22. The impact is huge. We're talking extracted project files and manipulated logic right on the operator's HMI screens. There's honestly nothing super exotic about this. It's literally just the automated targeting of exposed, unpatched devices. Which brings us to Section 2, Unmasking Structural Architectural Debt and the Death of the Air Gap Assumption. What this advisory really exposes is that this is not just a Rockwell problem. It's a massive, industry-wide structural crisis that's been building for decades. An entire generation of PLCs was essentially built with what we call architectural debt. That's the accumulated security deficit caused by relying on old legacy engineering assumptions. And the biggest culprit here? The myth of the air-gapped network. Hardware vendors just assumed that you, the operator, would never expose the device to the outside world, so they simply didn't build security into the foundation. Think about that legacy assumption for a second. OT networks are completely isolated, nobody's ever going to expose these devices, and if we need security, we'll just bolt it on later with a patch, right? But wake up to the 2026 reality. Devices are absolutely exposed to the internet. They're shipping with default credentials, or they have Telnet actively enabled right out of the box, and they're facing relentless automated exploitation. The bottom line is that bolted-on security just doesn't cut it anymore. Moving on to Section 3, Immediate Vendor-Neutral Mitigations. Let's look at CISA's first aid checklist. If you are operating an exposed utility or plant right now, you need to execute these 4 vendor-neutral steps immediately. Step 1, disconnect your PLCs from the public internet, literally right now. Step 2, route all your remote access through a hardened gateway or VPN, and absolutely enforce multi-factor authentication. Step 3, disable or firewall those vulnerable protocols. I'm talking VNC, Telnet, FTP. And Step 4, replace any controllers that aren't getting security updates anymore. Oh, and for those affected Rockwell devices, physically switch them into run mode. You have to do this first, because simply buying a different brand of PLC isn't going to magically fix a poorly architected network. Okay, Section 4, Evaluating Secure-by-Design Controllers and how we future-proof with WAGO and Turck. So, once you've stopped the immediate bleeding, what does a cybersecurity-forward PLC actually look like? Well, you should evaluate your future PLCs based on 3 concrete signals. First up, IEC 62443 certification. You're specifically looking for standard 4-1, which audits the vendor's secure development process, and 4-2, which certifies the actual device. Second, check the default network posture. Does the controller disable web services by default, or is it shipping with Telnet wide open? And third, look at their firmware update model. You want managed channels with cryptographic signing and actively published product security advisory feeds. It's really interesting to compare two very different but highly effective defensive philosophies here from WAGO and Turck. WAGO tackles this with a massive focus on firmware and software security. They're using an IEC 6243 certified process running on real-time Linux bases with encrypted TLS, native OpenVPN, IPsec, and integrated firewalls that disable web services by default. Turck, on the flip side, approaches the problem through architectural isolation. They use IP67 field mount block I/O, which completely eliminates the need for centralized enclosures. That inherently shrinks the blast radius if a compromise happens. They also rely heavily on headless IoT gateways to consolidate devices.
Let's look at how this plays out across WAGO's lineup. Take WAGO's PFC200 platform. It's a clean sheet, next-gen design that features network segregation by default, plus Marine and ATEX Zone 2 approvals for explosive environments. Then you have the PFC200 G2. That's basically your heavy-duty workhorse, offering integrated 4G LTE and handling extreme temperature ranges. For the machine builders out there, the Compact Controller 100 gives you tightly integrated I/O to strip away unnecessary attack surfaces. And finally, the Edge Controller 400 is an open Linux platform that runs isolated, containerized apps, making OT-IT convergence super secure.
Now, Turck's offerings perfectly map to their architectural isolation strategy. Their TBEN-L series compact PLCs are IP67 rated, meaning you can mount them directly on the machine out in the field, no enclosure required. So if a hack happens there, the blast radius is drastically smaller compared to someone breaching a massive centralized control cabinet. They also have the TX700 DIN rail PLCs, which are essentially headless IoT gateways. These consolidate the PLC and edge connectivity into a single device, so you don't have to secure a secondary bolt-on gateway. And for those really complex field bus master applications, the new TX800 series brings top-tier quad-core computing power to the table.
And finally, Section 5, a practical selection framework. Let's match the PLC to the profile.
Let's tie all of this together. How do you actually choose? Well, whether you're overhauling a legacy system or starting totally fresh, your physical architecture has to dictate your defense. If you're doing a new build and need a long-lived platform, specify the WAGO PFC300. That gives you a support runway straight to 2035. For standard process line controls, the WAGO PFC200 G2 or Turck's distributed TBEN-L models are a perfect fit. OEM machine builders, you'll want to look at the WAGO CC100 or Turck's TX700. If you're outfitting a remote energy or water site, the cellular integrated WAGO PFC200 X tier is amazing because it removes the need for separate vulnerable cellular gateways. And for industrial IoT edge analytics, the app-based WAGO Edge Controller 400 or Turck's TX800 are exactly what you need.
As you look at your own infrastructure and think about the legacy assumptions that might still be lurking in your networks, I want to leave you with this one critical question to consider regarding your own architectural debt. Are your critical operations protected by design, or are you just hoping for the best? Thanks for joining me on this explainer. Stay secure out there.